Okay, welcome back for part two of rational exponents. Today we're just going to talk about rewriting rational exponents when the numerator is not 1. So that means we're going to rewrite numbers such as 2 to the 2/3, x to the 3/5, or 4 to the 5/7. But before we begin, it's important that we remember how to do a few things regarding fractions. So for instance, if we have a fraction, we could easily split that fraction into two parts. One part will have a numerator of 1, and the other part will be the numerator of the original fraction. Okay? So this will be 1/5 times 4. And this will be 1/7 times 5. And this will be 1/2 times 5. Okay, so it's important that we remember that we could multiply these two fractions to get this single fraction. Okay. It's also important that we remember the power rule. So if we had a power and we were raising it to a power, say we had 4/3 and we raised it to the 5th, then you would simply take the two exponents and multiply them. So 4 to the 3rd to the 5th would simply become 4 to the 3 times 5, which is simply 4 to the 15th power. And this would simply be 9 to the 4 times 6, or 9 to the 24th. Okay, so now once we know how to write the fraction with the numerator of 1 and the whole number, and also how to raise a power to a power, you simply multiply the exponents. Now we want to remember, whenever you have a rational exponent, the denominator basically tells you what the root is. So 4 to the 1/3, for instance, would be the cube root of 4. Okay, so now let's take a look at rational exponents where the numerator is not 1. So the first thing we're going to do is we're going to use what we learned here, and we're simply going to split this fraction into 1/2 times 3. Okay, now remember, whenever you're multiplying the two exponents together, that is the same as raising a power to a power. So this is basically 2 to the 1/2 to the 3rd. Okay, and we know that 2 to the 1/2 is simply the square root of 2. So that is going to be the square root of 2 to the 3rd power. And the same thing here, we could rewrite this as 4 to the 1/3 times 5, which is then going to give me 4 to the 1/3 to the 5th power, or cube root of 4 to the 5th power. Okay, so it's important that when you're first starting off, you don't skip the steps, you go through the process, and eventually when you've mastered this concept, you can go from the first step to the last step, or skip as many steps as you want to. Okay, so let's do another problem. We have 6 to the 7/5, and this is just going to be 6 to the 1/5 times 7, or 6 to the 1/5 raised to the 7th power, or the 5th root of 6 raised to the 7th power. And doing the same thing, this will be 8 to the 1/3 times 9 equals 8 to the 1/3 to the 9th power, which is going to be the cube root of 8 raised to the 9th power. Now, in the next video, we'll talk about how to actually simplify the cube root of 8, and also we'll look at simplifying other radicals. Now, some of you would have noticed that when you have 9/3, that's basically 8 to the 3rd power. Okay, so the cube root of 8 to the 9th power is 8 to the 3. In the next video, we'll see how to actually simplify the cube root of 8. Okay, now pause your video and do these 4 problems. Okay, so you should have had enough time to do your problems. Here are the answers. You can compare your answers to mine. If you notice you've made any mistakes, simply go through the video again and see if you could find where you made your mistake. Okay, that concludes this portion of the video. The next video we'll look at simplifying rational exponents. So for instance, 4 to the 3/2, we'll look at how to actually simplify that by going through the process. Hope you enjoyed the video. Follow me. Come back next time.